Hey guys, so I'm coming at you with a little, wow, that's blurry. Never mind, we're good. With a little bit of a different style today. So, there'll be different ways that you see me recording the videos. Today I'm just using paper, so this way I can write on the same paper as you have. So this way you can see everything I'm doing from there. So, I'm gonna start off by going over that do now. So your do now, if 5 times 3 is another way of writing 3 plus 3 plus 3 plus 3 plus 3, write the following using addition. So we took that multiplication as a repeated addition problem and just repeated that addition. So number 1 asked you to do the same thing for 8 times 4. So this actually could have been done 2 different ways. Sorry about the lighting. I can't seem to get rid of that shadow. So you're going to have to deal with that for now. Sorry. So 8 times 4, there's 2 different ways to write it. You can either write 8 of the number 4. Keep writing 8 of them. 1, 2, 3, 4, 5, 6, 7, 8. Or you can actually write 4 of the number 8s. It's a lot less of them, easier to write. In the end, they both give you the same thing. So number 2 asked you to do 6 times 2. So you could either write 6 of the number 2's or 2 of the number 6's. Okay, 3 was 3 times 9. So either 9 plus 9 plus 9 or, oh, this is a long one. Why did I do the long one? 3 plus 3 plus 3, forgetting that I'm going to have to write it for you guys too. And you can't see that. That would help, huh? 7, 8, 9. Okay? So there's 9 3's added together, or there's 3 9's. Alright, number 4. So this one was a tiny bit different. 5 times x. So this one, there's only going to be one way to write it, because you can write 5 of the number x. Okay, I know technically we call it letter, but I'm saying number x in this case because x stands for some number. There's no way to write x 5's because we don't know what x is. So this is it. So number 5. Same thing. I just noticed I wrote it without a multiplication sign in the middle. This is the standard way that mathematicians are going to write it. Mathematicians are lazy. We don't like to write as many things if we don't have to. So we just smush it together as a 7x. So that's going to be the same thing. It's going to be 7 x's. All added together. Okay? So check this over, make sure you have this. And then from here, normally we would go into going over your homework, but you had no homework over the weekend. Well, kind of. You had to finish those 2 classworks, but I already went over them in the video from last week. So we're just going to jump right into our lesson today. So you have that new packet out that you should have grabbed when you grabbed your Chromebook, which is your Lesson 1 packet, Module 3, Grade 7. This is what this always says on top, okay? So Grade 7, Module 3, this is Lessons 1 through 6 is the whole packet. So it's going to take us this week, and it's going to take us into next week as well. Okay? So we're on Lesson 1, so generating equivalent expressions. So it talks here about any order, any grouping. This is with addition. So don't try and get those mixed up. It has to be only addition in the problem for us to be able to use this. Okay? So letter A says to rewrite 5x plus 3x and 5x minus 3x by combining like terms. So that's the skill we're working on today, is we're learning how to combine like terms. Okay? So they want you to write the original expressions and expand each term using addition. So we're going to expand these same way we just did in our do now. So 5x, there's going to be 5 of them. And then we have 3x, so it's going to be 3 more. Okay. So we have 5 here from the 5x and 3 here from the 3x. So altogether we have 8x, 8 x's. Okay. If we were going to subtract this here, we have 5 x's. And then you're taking away 3 x's. Okay, so you can either write it like this, or you can write negative x, negative x, negative x. and the rest are all adding like they originally were. Okay, so x minus x, those are going to cancel out. Another x and minus x cancels out, and one last one does. Okay, so we're end up with 2x because we had 5 x's and we took 3 of them away. We were only left with 2. All right, letter B. So find the sum of 2x plus 1 and 5x. So we can do this a long way like we did above. So 2x plus 1 is x plus x plus 1. And 5x is x plus x plus x plus x plus x. Okay? So we want to find the sum, so it means we're going to combine like terms. So like terms are things that are similar. It's like apples and oranges, and they use that example all the time when we talk about combining like terms in math. So we have x here, and all the way down here. So we have a total of 7 x's, and then the lonely plus 1 after that. So all we did was just added 2 and 5 together. It's like saying I have 2 students, and then I have a teacher, then I have 5 students, so altogether I have 7 students and 1 teacher. So you can add that 5 and that 2 together and just get that 7. If you forget that rule and you need to write it out the long way, that's perfectly fine. It just takes more time, especially when we get into the larger numbers with this and negative numbers, okay? So 2 ways to do this. One way is to just write it all out. And your second way would be to say, okay, well, 2x plus 5x, 2 plus 5 gives us 7, so 7x. Okay? All right, so I'm going to skip C. It's up to you. You can either do C right now, have it checked by me before you move on to example 2, or if you prefer, watch the whole video, then go back and work on each of the problems. Either one, it's fine, but you are responsible for C. Okay, so we're going to move on to example 2. This one is actually talking about multiplication. So again, they're talking about any order, any grouping. So any order is your commutative property. You can change the order. Any grouping is your associative property. It's who you associate together, who you kind of put together. And that's just saying that any order and any grouping are equal. So it's only addition and multiplication. That's not subtraction. It's not division. So you can never use them there. Okay? So I want you to find the product of 2x and 3. So if we go back to that repeated addition thing, this is 2x times 3. So it's 3 of the 2x's. Okay, so 2x plus 2x plus 2x, if you wanted to write it all the way out, it would take forever, but that's okay. 1, 2, 3. Yeah, so altogether we have 6 x's, okay? That's, again, a long way to do it. The short way would just be to multiply your 2 and your 3 and just keep your x, okay? It's like saying 2x is 2 teachers. Well, 2 teachers times 3 is going to be 6 teachers. So you just multiply those 2 numbers and then just add that variable on the back of it, okay? So we're going to do a few more of these multiplication ones together. I'm going to kind of skip around, so I'm going to do A and D, that's why they're circled, and then you're going to do B and C afterwards, okay? So A, well, this is actually the same thing that's up here. So just 3 times 2 is 6, and keep my x. All right, and then D. So beginning part is actually the same again. 3 times 2 times x. So this is kind of like, think of this as 2 separate problems. So think of this first. 3 times 2x, since multiplication comes before addition in the order of operations. So 3 times 2x is going to be 6x. Our plus is still there. Now we have 4y times 5. So we do 4 times 5 to get 20 and keep our y. So normally from here you would try to combine like terms. So you would try to actually add up those like terms, but you can't here, okay? This is 6x and this is 20y. They're completely different things. They both are variables, but they stand for different things. This is like saying 6 teachers and 20 kids. All of a sudden we don't have 26 teacher kids. Like, it doesn't work like that. You have one or the other. We can't just merge them together into different ideas. Okay, so this would stay 6x plus 20y, and you're completely done from there. Okay, so Again, at this point, you're either doing B and C. Actually, there's one in the back. Two, we're going to do both those together. So you're either doing B and C right now and having me come around and check it, or you're going to keep going with the video, come back to all these unfinished problems afterwards. Up to you. Okay? But we are flipping. You're staying with me. Okay? We're going to look here at letter E. So this one just had an extra term in it. That's why I'm doing it with you and not having you do it on your own. It's the same thing. Just takes longer. Okay? So kind of think of it as 3 different problems. So 3 times 2x. We've done that so many times so far today. So that's 6x. Now you do 4y times 5. So you multiply your 4 and your 5. You get 20. And you keep your y. And this last one, we do 4 times 2. It's 8. And we keep our z. Okay? So now, x, y, and z, all different things. Teachers, students, principals, whatever you want to think about it. Apples, oranges, bananas. They're different things. You cannot combine them any further. That's it. Your question is simplified completely. It's done. All right, so F. So I did want to talk about this one. So Alexander says that 3x plus 4y is equivalent to 3 times 4 plus x times y because of any order, any grouping. So we did talk about any order, any grouping on the front page, but it has to either be all multiplication in the problem or all addition in the problem. So he is not correct. And one of the ways we could have determined that is we could actually multiply this out, and you get 12 plus xy, and this is 3x plus 4y. Okay, those are 2 entirely different expressions. No, he is not correct. We'll say you must have all addition or all subtraction. Oop, multiplication. Okay, so it must be all addition or all multiplication. You cannot mix and match them. Numbers don't work that way, unfortunately. Okay. All right, so now this last section we have here, we are actually going to be substituting in values. We have done this before, recently-ish, and so we're going to do it again. So they say use any order, any grouping to rewrite them. We're going to combine like terms. We're going to do a lot of different things. Basically, at the end of the day, we want one answer. So they want us to simplify this out and then check with a equals 3 for both of them. Okay, so simplifying it out, we have 3 times 6, a. So we just do 3 times 6, we get 18, and we have a. So what we're going to want to do is we're going to want to double check that both of these are equivalent. Okay, so 3 times 6a is going to be 3 times 6 times 3, because a is 3. Okay, so 6 times 3, order of operations, so let's do parentheses first. So we get 3 times 18, which I should have that done already. It's 54. Okay? And then here, you're going to do 18 times a, which is 3. So 18 times 3 again is 54. They check. So this is actually equivalent. That's correct. All right, so we're going to skip 5. You're going to do 5. We're going to go to 6. So order of operations is not what we're doing right now. Sorry, that was wrong. But you're going to multiply your numbers. You have 5 times -2. So this is your spun rules. We're pulling out those rules. Spun rules are never going to go away, okay? 5 times -2, they're unlike signs, so it's going to be negative. 5 times 2 is 10, and we keep our r. Okay? Now we're going to check them both like we did up here. So 5r times -2 and -10r. The number they're having us use is -3. So this is 5 times -3 in the first set of parentheses. Okay, spun rules again. 5 times -3 is -15. And then -15 times -2 is going to give us +30. Okay, here, -10 times r, and r is -3. Same signs, positive. 10 times 3 is 30. They check. That is correct. Okay? This is not going to have to be done every single time you do this kind of question, but it doesn't hurt, and it's a good way to kind of check yourself. Okay? And 8, we're almost done. We have 2 more that I'm going to do 8 and 10 with you, and then you're done for the video, and you're going to go ahead and finish every single question that is on the first page, front and back of this packet, okay? So here, you're going to treat this like 2 problems again. So -4 times 3 is going to give you -12. We keep s. 2 times -t, so this is like a -1t. So 2 times -1 is -2, and you keep the t. Right? These are not like terms. You cannot combine them. They're like students and teachers. They're not student teachers. They're not combined together. They are separate things. Okay? So we want to check it for both sets of numbers here. Okay? So I have -4 times 3s plus 2 times -t. And what we want is we want s to be 1/2. I'm going to go down this time. So 3 times 1/2 plus 2 times, -3. So -t is -3. So it's +3. Okay? So order of operations says to do the parentheses. 3 times 1/2 is 3/2, or 1 1/2. And 2 times 3 here, we'll wait on that. Okay, so now we did parentheses. So remember PEMDAS if you need to. -4 times 1/2. So SPUN rule says it's a negative. 4 times 1 1/2 is going to be 6. And then 2 times 3 is 6, so altogether this gives you 0. Okay? And then -12s plus -2t. S again is 1/2. T again is -3. So -12 times half. Half of 12 is 6. Keep the negative because it's spun, unlike signs negative. -2 times -3, that's your SPA. Same sign's positive, so it's +6. Add a 0, it checks. This is correct. All right, last one. I saved the best and the longest for last. You want to treat this like 3 separate problems. So we're starting here. 7 times 4g. 7 times 4 is 28, so it's 28g. 3 times 5h, so 3 times 5 is 15. Keep the h. 2 times -3 is -6. Keep the g. Okay? So here, we have one last step. Up here we stopped because you had s and t. Those are not like terms. But now you have this g and this g that are like terms. The reason I boxed them the way I did, I grabbed the number and any symbols that it had before it. So I grabbed plus -6g. So 28 plus -6. Okay? That's going to give you a positive 22g. And then the 15h is just brought straight down. We're going to talk more about this moving forward, but just bring that one straight down with you. Okay? So that's your new number. That's the one we want to check. 22g plus 15h. G is 1/2. And h is 1/3. Okay, so half of 22 is 11. 1/3 of 15 is 5. So this right here gives you 16. Okay, we're going to need a little more room for that last one because it's really long. Let me just rewrite this first, and then I'll talk you through it, and then you'll be on your way working. Okay, G is 1/2, so 4 times 1/2. 3, 5 times 1/3. Ooh, that's going to be ugly. 3, and G is 1/2. Okay, so parentheses first. So we have to do all this multiplication that's inside the parentheses first. So we're going to do 4 times 1/2. So we have 2. 5 times 1/3 is going to give you 5/3. Or 1 2/3. Negative 3 1/2 gives you negative 1 1/2. You could have kept 3 halves. You could have kept these all as improper fractions, okay? That's fine. And now we multiply. 7 times 4, or 7 times 2 is 14. 3 times 1 2/3 is 5. 2 times negative 1/2 is negative 3. Now we add. 14 and 5 is 19. 19 plus negative 3 is a positive 16. They add up. So this is your final answer. Okay, so all this work on this right here, that was just a check. On a normal question, you don't have to check. It told you to check on this question though, right up here. Okay. If it didn't tell you that, you could have just given me these answers on the left here and been done. But we want to make sure that you are able to check them as well, and you know that that's a possibility if you need it. Okay. So at this point, you have 5, 7, 9 here, and you have the questions on the front that you are working on. If you did not finish the ones on the front already, you're going back and finishing those. If you need me, I'm around. Make sure you raise your hand. I will be checking in with you anyway on those other questions to make sure everyone's doing okay. So go ahead, get to work.